Greetings from K.S.Rangasamy College of Technology. Myself Prakash P, Assistant Professor, Department of Mechanical Engineering, K.S.Rangasamy College of Technology, Tirchangur. Today we are briefly discuss about the course of Quality Control and Reliability Engineering under the module of Statistical Process Control. First of all, you should know what is Statistical Process Control, SPC. SPC, Statistical Process Control, it is a method of quality control which helps to monitor and control a process. The main purpose of statistical process control, we have to reduce the waste or scrap. This helps to ensure that the process operates efficiently and producing more conforming product. Quality. Quality, it is nothing but it is in structure due to consistent use of well-developed methods and procedures. It is a measurement device. Next one is the evolution of quality. How the quality will evolve means, first one is quality control, quality assurance, and then total quality management. The concept of quality has highly existed for many years, though it means have changed and evolved over time. In earlier 20th century, the management mean inspecting product to ensure that they meet the specification or requirement. Quality control, it is nothing but it is a process which helps to ensure that the product quality is maintained or improved. Quality control involves testing of unit and determining and if they are within the specification for the final product. Quality inspection is the process checking the product or service to ensure that it will meet the required standards or specification. This involves examining the product or service for defect or error that they impact its safety or quality. Next one is the quality assurance QA. It is a set of systematic activity and process performed to ensure that the product or service which meets the specified quality requirement. The primary goal of this quality assurance is to identify and prevent defect or error in the product before they reach the customer or end users. Total quality management, you can see that picture. TQM, it is an process product service. Similarly, we have implementation, organization commitment, some principal employees leadership. These are which we are interlinked. We have to get the good quality product during product development. Total quality management, it is a management philosophy and approach that it aims to achieve continuous improvement in quality process across all aspects of an organization. It emphasizes the involvement of every employee which helps to focusing on producing customer expectations. Next one is the 7 SPC tools which we are used to control or monitor the process. First one is a cause and effect diagram, check sheet, control sheet, histogram, Pareto chart, scatter diagram, and then flow chart. Cause and effect diagram which was introduced by Kauro Iskawa. It is other name also known as fishbone diagram or Iskawa diagram. The main purpose of this cause and effect diagram is to identify all root cause behind the problem. Once a quality related problem we have defined, after that what are the factors which occurs leading to that problem, again it will be identified. After that further keep identifying the sub factors related to the identified factor till we are able to identify the root cause of the problem. Finally, as a result, we get a diagram with branches and sub branch. What are the factors and sub factors which involved in the form of fishbone diagram? You can see in a manufacturing industry, there are various categories are mentioned below like people, method, measurement, machine, environment, and material. To identify the source of variation and causes, what are the causes which will affect the entire system? First of all, you can see the cause and effect. What are the causes? Under people, maybe on that particular day, the people, the employee may be an absent or leave. There should be a communication barrier. If a worker having a lack of skills or improper management. So these are the activities under people, the major causes will occur. Similarly, having methods, lack of planning, poor task prioritization, you should prioritize which order will come first and second. You should prepare that. Outdated technology we are using, outdated process which we are using. These are the causes which affects the entire quality control. Next one is a measurement. Under measurement, what are the causes will occur means lack of accountability, no tracking on progress, no short-term goals, inappropriate use of tools. Similarly, for under machine, there is a machine breakdown, lack of maintenance, power energy crisis, and no backup machine. So similarly, environment, industrial health hazard, extreme temperature, small workstation, workplace accident may be happen. Similarly, under material, no buffer stock, unavailable spare parts, shortage in raw material, defect in supplied items. So these are the major causes which will affect the entire manufacturing industry. Next one is a histogram. Histogram, it is a basic tool of quality control which helps to represent and categorize of continuous data. We can represent, you can see that graph, there is no gap between bars unlike the bar gap, which will help to signify that the data is continuous, and width of the group which is equal. For example, in an amusement park, we want to identify or study the number of visitors in different age group. So based on the visitor, they want to include or modify the different rides or theme. So this is a basic example. You can see at bottom there is an age group, and in y-axis you can see the visitor. We can draw a graph between histogram or histogram of visitor versus age group. You can see the 20 to 25 age group people having have at that age group are visiting, more number of people are visiting the amusement park. So it should be in continuous data. We can easily categorize at what time, how much age group people are visit. We can, with the help of histogram, we can easily identify. Next one is a check sheet. Check sheet, it is nothing but it is a structured prepared form for collecting and analyzing data. The main purpose of this check sheet is used to for collecting and analyzing data. You can see different types of defect, major and minor defect. So on what day the defect will occur, and per day how many count will occur. You can see that in that graph right side there is a tabular column. You can see there is a rusted item. Monday has shows then 4 component having rusted. Similarly Tuesday 2 component, Thursday and 2 component, Friday 1 component. In left side we have mentioned what are the defect will occur. Reused item, items with scrap, dirty, broken, cracks, main body dent, missing component, labeling error, damage in packaging, wrong item used, film on parts, void in casting, incorrect dimension, so failed to pass a quality test. So these are the different types of defect based on major and minor defect. We can create a count per week, how many component will defect, we can easily identify it. So you can consolidate, we can equal to from left hand side, and at bottom x-axis and y-axis we have considered count that totally 52 components we are making a defect. So this sheet will helps to identify where we are lagging and how the defects occur and how to control that defect and how to provide some good quality of product. So this generic data collection and analysis tool that can be adapted for wide variety of purpose, and consider one of the 7 basic quality tools. Next one is a Pareto chart. Pareto chart is named, developed by Vilfredo Pareto. So he identified that concept. There is an 80-20 rule, which means 80% of problem or failure which is caused by 20% of factors. So that referred as a vital few. So it will be categorized as vital few and trivial many, where it was remaining 20% of problem which is caused by failure, caused by 80% of major minor factor which is referred as trivial many. You can see that cause and frequency, there is a graph plot between causes and frequency. At x-axis you can see rusted, scratch, dirty, broken, dent, cracks, pinhole, gap, others. These are the causes which we are identified. How much component you can see this, how much count. You can send particularly rusted, scratch, dirty, broken, dent, cracks, pinhole, gap, others. So cumulative percentage we can able to calculate. So this concept which will helps to improve based on that causes, we have to improve that particular quality process method. Scatter diagram are also known as a scatter plot, which is basically a statistical tool. There should be two variable. One is a dependent variable, which we are graphed on y-axis, and independent variable on x-axis. So we have plotted as a dot on their common intersecting point. So we are using an equation that is y equal to fx plus c. F of x is function where c is the arbitrary constant we are using. You can see that graph, positive linear correlation, negative linear correlation, there is no correlation. The points which we are randomly placed, non-linear, there is a chain-like structure. So these are the different correlation: positive correlation, negative correlation, no correlation, and non-linear. Next one is a control chart, which was called also known as an Shewhart chart, named after Walter A. Shewhart is basically a statistical chart which helps to determine the industrial process, whether the process within the control or not, whether it is to meet the customer defined specification limit or not. You can see that the graph, there is a 3 limit. You can see there is a graph plot between time and measurement. You can see the lower control limit and upper control limit, and in between there is an process is average. You can see that point number 3, which is out of control, because there is a limit, there is an upper control, there is a lower control limit. What are the points which we cross that any limit, that particular point is defective. This chart will help to identify whether the process within the limit or not. So out of limit, the entire process or the quality of the product is particularly failed. That should not meet out that required specification. So this control chart will help to identify whether the process which is meet that required point or not. Next one is a flow chart. Flow chart, it is a diagram that shows that it is a step-by-step flow of operation to get a particular solution of a problem, or we have to figure out the sequence of process. So generally flow chart, which we are used in designing and documenting complex problem, it helps to visualize what is going on, what will be processed, and the people will get the better understand about the process. You can see that there is a flow chart of start, and then fabricate shop drawings and consultant approval. After that, if it is okay means, then go for documentation, and finally we have to display, that we call as in end the product which will reach to the customer. So in general, this is the flow chart we are using. You can see the start, and then fabricate shop drawing. After that, consultant approval, which means what are the drawing we have done. For example, we have to make a chair. It should withstand a weight of 50 kg, means we have to draw a chair based on the material we are choosing, like wood, steel, like plastics, like that we have to design the chair. After that, the consultant approval means if you are giving an axial load of 50 kg on that particular chair, it should withstand. Otherwise, if it should not withstand, means you have to revise that fabricate shop drawing. Then you go for a designing. After that, based on the material change, again we have to check and apply the load on 50 kg. Whether it withstand, means then we go for an final approval. Then go for an documentation. That means if it withstand 50 kg, means then go for an manufacturing. After that, it will go for an end user. Thanks for watching. Keep learning and growing. K.S.Rangasamy College of Technology.